You've probably heard it a million times, right? That we only use 10% of our brains. It's this super tantalizing idea, but is there any truth to it? Well, in this explainer, we are going to dive deep into the science, bust the 10% brain myth, and discover the absolute powerhouse that's already sitting between your ears. I mean, this is the question that has captivated us for generations. The idea that there's all this untapped potential, this hidden superpower just waiting to be unleashed. It's the stuff of sci-fi movies, for sure. But what's the real story? Yeah, the promises of the 10% myth are pretty epic. We're talking superhuman intelligence, instantly mastering any skill. I mean, who wouldn't want that? But are these claims based in actual science, or are they just pure fantasy? All right, let's just get this out of the way. The 10% brain myth is exactly that, a miss. But man, is it a persistent one. Let's take a quick look at just how widespread this idea really is. This is not some fringe belief, you guys. A staggering 2/3 of the public buys into it. And get this, almost half of science teachers believe it too. It just goes to show you how powerful a good story can be, even when the evidence just isn't there. So how did this whole thing even get started? Well, it's basically a classic case of a scientific game of telephone. You have a psychologist making a comment about our mental potential that gets twisted, then early brain mappers find some blank spots they call silent areas, and then a simple misunderstanding about different types of brain cells gets tossed in, and boom, a myth is born. Okay, now let's get into the hard science that completely blows this myth out of the water. And it all starts with one simple but really powerful fact. Your brain is an absolute energy hog. Think about this for a second. Your brain is only about 2% of your body weight, but it devours 20% of your daily calories. From an evolutionary standpoint, that is a massive investment. It just makes no sense that nature would design such an expensive organ to only run at 10% capacity. And just to put that in perspective, a rodent's brain uses about 5% of its body's energy. A monkey's uses 10%. Ours, 20%. It's completely off the charts. That's the energy price we pay for our incredible intelligence. And if you think that's wild, get this. In a developing infant, the brain uses a staggering 60% of the body's total energy. That is a huge commitment of resources, all to build that complex neural network that makes us who we are. So what exactly is all that energy fueling? Well, it's a neural network of mind-boggling complexity. Let's dig into the raw numbers for a second. 86 billion. Let that number sink in for a minute. That's more than 10 times the number of people on planet Earth, all packed into the space between your ears. Each one of those neurons is like a tiny computer, forming trillions of connections. It's this insane density that gives us our cognitive edge. But how in the world do we fuel this thing? An ape, for example, has to eat for 8 hours a day just to power its brain. So what was our secret weapon? Cooking. Seriously. By essentially pre-digesting our food, we made it way easier to absorb calories. And that freed up the energy we needed to evolve these bigger, more complex brains. Okay, so we've established we have this incredibly powerful, but also incredibly power-hungry brain. So how does it manage its energy budget? The answer is this really clever and elegant strategy called sparse coding. Sparse coding is basically the brain's secret to amazing energy efficiency. It's all about working smarter, not harder. By only activating a small fraction of neurons at any given time, it can process huge amounts of information while using as little power as possible. It's a brilliant piece of biological design. And to really get why this is so critical, just think about this. Just keeping your neurons on standby, just ready to fire, eats up half of your brain's entire energy budget. Activating all of them at once would be like trying to run a city's entire power grid through a single extension cord. It would just instantly overload. So how does this sparse coding thing actually work? Well, you can think of it like a giant orchestra. You don't have every single instrument playing at full blast all the time, right? Instead, different sections come in out to create a complex piece of music. Your brain does the same thing, activating different little clusters of neurons for different tasks, creating this rich, dynamic tapestry of thought. And, this energy constraint is the exact reason why true multitasking is a myth. When you think you're doing two complicated things at once, you're not. You're actually just switching your attention back and forth really, really fast. And that's way less efficient and leads to way more mistakes. It's your brain telling you, hey, focus on one thing at a time for best results. So, the 10% myth kind of paints our brains as these lazy, underachieving organs. But the reality is so much more impressive. Your brain is an absolute marvel of efficiency and power, a finely tuned instrument for navigating the world.
So let's just sum it all up. You use your whole brain, just not all at the same time. It's an energy-guzzling machine, packed with 86 billion neurons that are managed with incredible efficiency. The big takeaway here? Your brain isn't some locked room waiting for a key. It's a high-performance engine, and it's already running beautifully.
So, the next time you hear someone mention the 10% brain myth, you'll know the real story. The real magic of the human brain isn't about some vast, untapped potential. It's about the incredible, mind-blowing efficiency and power of the potential you are already using every single second.